Welcome to the deep dive. Today we're digging into the early Jurassic, really getting to know a dinosaur called Berberosaurus.
That's right. We're working from a scientific overview, covering its discovery, its tricky classification, and the world it lived in.
Yeah, and our goal here is to figure out why Berberosaurus matters. What's its story tell us about early meat-eating dinosaurs, especially out of North Africa? And maybe its connection to ceratosaurs.
Mm-hmm.
Okay, so let's start with the name, Berberosaurus. It feels very specific location-wise.
It absolutely is. Berberosaurus literally means Berber lizard. It's a direct nod to the Berber people of Morocco, which is where the fossils turned up.
That's a nice touch.
Yeah. And the species name Liassicus, that just points to its age. The Lias epoch, early Jurassic.
Right, the Leia. So this Berber lizard, where exactly in Morocco was it hiding all those millions of years?
It was found in the central High Atlas Mountains. There's a place called Tournout near Ouarzazate. The bones were in these rocks called the Tournout Continental Series. That's basically part of the Zeal Formation.
And finding it wasn't easy, I gather.
No, definitely not. It wasn't just lying on the surface. Expeditions started back in the early 2000s, and it took, I think, 6 years of digging in those local red beds.
6 years, wow. That's dedication. So finding Berberosaurus there, why is that so significant?
Well, a couple of big reasons. First, it's the oldest formally identified theropod meat-eating dinosaur we have from North Africa. The early Jurassic record there is, frankly, pretty sparse.
Right, a big gap in the map.
Exactly. So Berberosaurus gives us this really valuable, rare look into that time and place. And maybe even more excitingly, it could be the oldest known ceratosaur.
The oldest ceratosaur. Okay, now that is interesting. So let's talk evidence. What did those 6 years of digging actually uncover? What bones are we talking about?
The first big find, the main one really, was a partial skeleton from a subadult. So not fully grown, maybe like a teenager. And it was postcranial, meaning no skull parts in that initial find. It included a neck vertebra, part of the sacrum, the fused hip vertebrae, a metacarpal from the hand, a femur, the top part of a left tibia, both fibulae, those are the lower leg bones, and a piece of another femur. All carefully documented, of course.
That's a decent amount to work with, even without a skull. And you mentioned newer finds, too.
Yeah, more recently, expeditions in the same area turned up more material. Things like the axis, that's the second neck vertebra, a postorbital bone, which is from the skull.
Okay.
Some other skull fragments. And teeth, too. They're still being studied, so we might learn even more about his head and teeth soon.
So even from those first bones, were there things that made scientists say, this is different? Any distinguishing features?
Oh, absolutely. Several things stood out. That neck vertebra, for instance, was highly pneumatic.
Pneumatic, meaning?
Like full of air spaces. It would have made the neck lighter. The vertebra body, the centrum, was short, and there were holes in the neural arch structure.
Okay, lighter neck structure. What else?
The neural spine on that neck vertebra, the fin-like bit on top, was low and short. That's different from dinosaurs like Dilophosaurus or Ceratosaurus.
Got it.
The sacrum, the hip structure, was quite arched and narrow in the middle. The hand bone, the metacarpal, had a really grooved end where it connected to the wrist.
Interesting detail.
And the leg bones, the femur, had a projection called the anterior trochanter that reached up unusually high near the ball joint. Again, different from Ceratosaurus. It also had a big platform area, the trochanteric platform.
Okay.
And the tibia, the shin bone, looked sort of triangular at the bottom, plus a distinct ridge on the fibula. Lots of little anatomical markers.
That's a checklist of unique traits. So based on all that, how big was this Berber lizard?
Estimations based on that first skeleton put it somewhere around 4.5 to 5 meters long, maybe 15 to 16 and a half feet.
Okay, decent size.
Yeah, and weight-wise, probably around 300 kilograms, so roughly 660 pounds.
Yeah.
And definitely a two-legged carnivore like other early ceratosaurs.
A significant predator, then, for its time and place. Okay, let's shift to the big question. Where does it fit in the dinosaur family tree? You mentioned its classification is debated.
That's putting it mildly. Yeah, it's been a bit of a moving target. When it was first described by Ronan Elaine and his team, they placed it as the most basal, the earliest known abelosauroid.
Abosauroids, like Carnotaurus later on.
Exactly. So if that was right, it meant that whole group started diversifying really early, back in the early Jurassic. They saw it as more advanced than things like Dilophosaurus or Ceratosaurus, but still very early on that abelosauroid branch.
Okay, so initial idea, early abelosauroid relative, but that wasn't the final word.
Not at all. Other studies came along, used different data sets, different methods, and got different results. In 2008, Carano and Samson suggested it was actually a more basal ceratosaur, outside the main group Neoceratosauria.
So closer to the root of the ceratosaur tree itself.
Kind of, yeah. Then, a year later, Xu and colleagues put it possibly with the Dilophosaurids, like Dilophosaurus. Their analysis actually ended in what we call an unresolved plotomy.
Meaning?
Basically, a point on the family tree where several branches split off close together, and the analysis couldn't quite figure out the exact order. So Berberosaurus was hanging out there with the Dilophosaurus and some other early theropods.
Wow, okay. Abelisauriid? Basal ceratosaur? Maybe a Dilophosaurid? That's quite the identity crisis. Any other positions it's held?
Oh, yes. In 2010, another study put it in another unresolved spot, this time sort of floating between Ceratosaurus itself and the whole Abelisauria group.
Still uncertain then.
Very. Then came 2018, 2 studies that year. One, describing Sultriovenator, suggested Berberosaurus was its closest relative, a sister taxon, both basal ceratosaurs.
Okay, a potential close relative identified.
But another 2018 study by Delcourt found it bouncing around again. Depending on the analysis, it popped up as a basal ceratosaur, sometimes a bit higher up within Neoceratosauria, or even again as a basal abelisauroid.
Goodness. It really seems like Berberosaurus is a key piece of the puzzle, but nobody's quite sure where it fits just yet.
That sums it up perfectly. It really shows how paleontology works. New fossils, new analyses constantly make us rethink these relationships.
And the overview mentioned something about Averostra. How does that concept fit in?
Right. So the original paper describing Berberosaurus came out near the end of a period when many scientists grouped coelophysoids, think Coelophysis within Ceratosauria. But around that time, the concept of Averostra was gaining ground. Averostra is a larger group that includes both Ceratosauria and Tedinore, Tedinore being the group that leads to things like Allosaurus, T-Rex, and birds.
Ah, okay. So Averostra basically splits the theropods differently at a high level.
Pretty much. And most research since then supports Averostra. This means coelophysoids are now generally seen as outside Ceratosauria, branching off earlier. This big picture shift changes how we interpret where early forms like Berberosaurus sit relative to these major groups.
That makes sense. The whole framework shifted a bit. So, given all that flux, what's the most recent placement mentioned in our source?
That overview highlights the Delcourt study from 2018 again. It places Berberosaurus within Ceratosauridae, so definitely in that broader Ceratosaur group as the sister group to something called Itrogensauria.
Itrogensauria.
Yeah, and Itrogensauria includes both the Ceratosauridae family, Ceratosaurus himself, and the Abelisauridae family, the Abelisaurs. So this suggests Berberosaurus is closely related to the common ancestor of both those major ceratosaur branches.
Okay, so still debated, but maybe homing in on a spot near the base of the ceratosaurs, possibly close to where the Abelisaur line branched off.
That seems to be the converging idea, yes. Somewhere significant right near the diversification of the main ceratosaur groups.
Fascinating. Okay, let's paint a picture of its world. The Azylal Formation. What does the geology tell us about life back then?
A lot, actually. We know the rocks are from the Pliensbachian to Taurocene ages of the early Jurassic, and crucially, they're terrestrial land deposits. They sit on top of older marine rocks.
Right, you mentioned that.
Which tells us the sea had retreated from that area by the time Berberosaurus lived there.
So what kind of land environment are we talking about?
It looks like it was likely a river and floodplain system. We see evidence of sand-filled river channels and fossil plant roots suggesting vegetated riverbanks.
Okay, rivers, plants.
But they're also thick gypsum deposits. Gypsum forms when water evaporates, often in salty conditions. This suggests the climate probably had distinct wet and dry seasons, maybe even a local chott like a temporary salt lake that dries out periodically.
Interesting. So a seasonally variable environment. Did that affect the plant life? What grew there?
Well, based on tiny plant fossils, mesofossils, the vegetation seems to have been dominated by ferns, cycads, and conifers. Pretty standard Jurassic flora, really.
And who else was living there? Any neighbors for Berberosaurus?
Definitely. The formation has also yielded to Zootosaurus, that was an early sauropod, a long neck.
Okay. Herbivores around.
Yes. And also remains of another big theropod, still unidentified. Plus, what looks like a coelophysid, maybe something like Coelophysis, we have bones from both juveniles and adults. And even a small sauropod. So a whole little ecosystem.
A diverse group? And the overview mentioned coastal influence and volcanoes.
Yeah, it seems during the Taurocene part of the early Jurassic, this area was near a coastline of the Tethys Ocean.
The ancient Tethys, right.
And the evidence points to it being a storm-influenced coast. Lots of powerful storms hitting the beaches. Plus, there's volcanic material mixed into the Azylal Formation from around the same time.
Wow. So Berberosaurus lived in this really dynamic place, rivers, floodplains, wet and dry seasons, storms off the coast, even volcanoes nearby. That's quite a scene.
This certainly sounds like it, a very active environment.
Okay, let's start to wrap this up. Thinking about everything we've covered, what are the main takeaways about Berberosaurus?
I think the key thing is that Berberosaurus is just this incredibly valuable data point. It gives us a rare look into early theropod evolution in North Africa, a really important time and place.
Uh-huh.
It's crucial for figuring out how ceratosaurs, and maybe allosaurids too, got started and spread. But as we've seen, its exact position, still very much debated.
Right.
And that really underscores how science works, you know? It's a process.
Hmm.
We find clues, we test ideas, we refine them as more evidence comes in.
Absolutely. And for you, the listener, understanding Berberosaurus, even with the uncertainties, highlights just how complex dinosaur evolution was. You see these early forms paving the way for later giants, and watching the classification shift. That is the scientific method playing out right there. We're seeing paleontologists actively trying to piece together this ancient puzzle.
Exactly, trying to map out those early branches on the theropod family tree.
So maybe a final thought to leave folks with. Given how much Berberosaurus has shifted around in our understanding, what kind of future discovery might finally lock down its position? Could it find somewhere else entirely, maybe South America or India, shed light on these early North African dinosaurs, and finally tell us where Berberosaurus truly belongs?
That's a great question. It really makes you wonder what's still out there, waiting to be found, that could rewrite the story all over again. The next fossil could change everything.